In this unit, we're going to introduce two new types of functions. One is the exponential function, and the other is the logarithmic function. And we'll get to that on a different day. But today I want to talk about what I would consider the parent function, sort of, and that'll make sense another day what I mean by sort of, but we're going to talk about the parent function of an exponential function. So let's look at this first one, and I'm going to start by graphing this first one by making a table of values. And honestly, I would worry more or worry less about shifts of functions on an exponential graph and worry more about making a table of values. So let's make a table of values on this one, and let's put some numbers in for x. Let's go with 0, 1, 2, 3, and then let's try -1 and -2. So I'm going to try those for my input and see what I get for an output. So I'm going to do 2 to the x power. So let's just start here with 0. 2 to the 0 power. Anything to the 0 power is 1. So 0, 1 is one of my points. And then I'm going to put in 1. So 2 to the first power is 2. So I have the point 1, 2 on the graph. 2 to the second power would be 4. So 2, 4. So I know that kind of looks something like this on this side. 2 to the third power would be 8. Let's go 2 to the -1. If it's 2 to the -1 power, a negative exponent really means fraction. So that's 1 over 2. So 2 to the -1 is 1/2. So when the input value is -1, the output value is 1/2. If I have 2 to the -2, that's 1 over 2 to the +2, which is 1/4. So it looks like this. So I can keep putting negative values in for x, but a negative exponent does not make a negative output value. A negative exponent simply makes a fraction. So this output is going to keep getting a fraction smaller each time. So it's going to look something like this. It's going to get closer and closer to this line 0, but never touch. Because you can never have 2 to any power and get 0 for the answer. If you have 2 to the 0 power, you get 1. If you have 2 to the first power, you get 2. If you have 2 to the -1 power, you get a fraction. So notice that you'll never have 0 for an answer. So in this particular case, this one is rising as I move from left to right. It's increasing. It doesn't matter what values I put in for x. I can put in negative numbers, I can put in positive numbers. But look at the range, look at the output value. See how I get fractions and positive numbers? I never get 0. This graph will never go below this line. So the range is going to be 0 to infinity. And notice 0 has a parenthesis instead of a bracket because 0 will never be an output value. I want to show you by just typing this into the graphing calculator really fast here. So I'm going to type in y equals and put 2 to the x power and hit graph. So you can see how this graph looks like my graph. Also, let's look at the table. Come on, graph. Grab a different calculator here. This one's frozen. Says that it's working, but I don't know if it is or not. So let me put another calculator up here. So let me type in the equation 2 to the x power and hit graph. So our graph looked like this. Notice it never drops down. But let's look at the table. Can you see how when I type in 0, I get 1 for the output. When I type in 1, I get 2 for the output. In fact, each of these is a multiple of 2. But whenever I hit negatives for my input values, this number just keeps getting to be a smaller and smaller number. I could keep scrolling here, but this would never go to 0, and it would never be a negative number. So the output will never be 0, and it will never be negative. Let's think about the end behavior here. This end, x, is approaching negative infinity. And when x is approaching negative infinity, y is approaching 0. It's getting closer and closer to 0, but never touches. Let's think about this end. This end, x is approaching infinity, and y is also approaching infinity. The asymptote, and that's a word we haven't talked about, but an asymptote is a line that the graph never touches as it goes away from 0. So you can see how this line gets closer and closer to 0 but never touches. So the asymptote for this one is horizontal, and it's at y equals 0. The y-intercept on this one is right here at 0, 1. All right, notice this one is rising. We call this one an exponential growth. All right, let's think about what happens on this one. This time I have 1/2 to the x power. So let's try those same numbers. I'm going to start with 0. 1/2 to the 0 power. Anything to the 0 power is 1. So it's going to go through the point 0, 1. Let's try 1/2 to the first power. 1/2 to the first power is 1/2. So input 1, output 1/2. Let's try the second power. 1/2 to the second power is 1/4. So input 2, output 1/4. So you can see now that this number is getting smaller and smaller and smaller, but it will never approach 0. It's going to be 1/4, 1/8, 1/16, 1/32. Okay, let's go to -1. 1/2 to the -1 power. When you have a fraction to the -1 power, the denominator becomes the numerator, and the numerator becomes the denominator. So to the -1 power is at 2. So you can see how this one is going to kind of climb like that. So again, the domain, I can put whatever number I want to. I can put -infinity to infinity. The range, again, the output value is going to start at 0 and go to infinity. So that means that the asymptote, again, is at y equals 0. This is a line that the graph is going to approach but never touch. The end behavior, let's think about this end. As x approaches -infinity, y is going to approach infinity. This end, as x approaches infinity, y is going to approach infinity. I'm sorry, y is going to approach 0. So x is getting bigger, but y is getting closer to 0. This one we call an exponential growth. So notice when the number, that's the base number, is bigger than 1, it's going to grow. But when this base number that you're taking to the exponent is a fraction between 0 and 1, this is going to be exponential decay. And we're going to talk more about that in a moment. Let's go ahead and go down here and let's just think about these. This one is a number between 0 and 1, so this would be decay. This is 1/8, but it's to a negative exponent, so this negative exponent is really going to make this 5 to the 8 over 1 to the x power. Now that's bigger than 1, so this one will be growth. This one is 7, it's bigger than 1, so it's growth. And this one is a fraction between 0 and 1, so it would be decay. So these are kind of going to be the examples that we'll look at and kind of really base all the other equations off of that. We'll shift.